Section 3.4, Testing a RESTful application with Spring. Automated tests are paramount to producing high-quality software. One of the goals for adopting a cloud-native approach is speed. It's impossible to move quickly if the code is not adequately tested in an automated fashion, let alone to implement a continuous delivery process. As a developer, you'll usually implement a feature, deliver it, and then move on to a new one, possibly refactoring the existing code. Refactoring code is risky, since you might break some existing functionality. Automated tests reduce the risk and encourage refactoring because you know that a test will fail should you break something. You'll probably also want to reduce the feedback cycle so you'll know if you made any mistakes as soon as possible. That will lead you to design tests in a way that maximizes their usefulness and efficiency. You shouldn't aim to reach maximum test coverage, but rather to write meaningful tests. For example, writing tests for standard getters and setters doesn't make sense. An essential practice of continuous delivery is test-driven development, TDD, which helps achieve the goal of delivering software quickly, reliably, and safely. The idea is to drive software development by writing tests before implementing the production code. I recommend adopting TDD in real-world scenarios. However, it's not very suitable when teaching new technologies and frameworks in a book, so I won't follow its principles here. Automated tests assert that new features work as intended and that you haven't broken any existing functionality. This means that automated tests work as regression tests. You should write tests to protect your colleagues and yourself from making mistakes. What to test and how in-depth to test is driven by the risk associated with a specific piece of code. Writing tests is also a learning experience and will improve your skills, especially if you're beginning your software development journey. One way of classifying software tests is defined by the Agile Testing Quadrants model, originally introduced by Brian Merrick, and later described and expanded on by Lisa Crispin and Janet Gregory in their books Agile Testing, Addison Wesley Professional, 2008, More Agile Testing, Addison Wesley Professional, 2014, and Agile Testing Condensed, Library and Archives Canada, 2019. Their model was also embraced by Jez Humble and Dave Farley in Continuous Delivery, Addison Wesley Professional, 2010. The quadrants classify software tests based on whether they are technology or business-facing and whether they support development teams or are used to critique the product. Figure 3.7 shows some examples of testing types I'll mention throughout the book, based on the model presented in Agile Testing Condensed.
Figure 3.7. The Agile Testing Quadrants model is helpful in planning a software testing strategy.
Following continuous delivery practices, we should aim at achieving fully automated tests in 3 out of 4 quadrants, as shown in Figure 3.7. Throughout the book, we'll mainly focus on the bottom left quadrant. In this section, we'll work with unit tests and integration tests, sometimes called component tests. We write unit tests to verify the behavior of single application components in isolation, whereas integration tests assert the overall functioning of different parts of an application interacting with each other. In a Gradle or Maven project, test classes are usually placed in a src/test/java folder. In Spring, unit tests aren't required to load the Spring application context, and they don't rely on any Spring library. On the other hand, integration tests need a Spring application context to run. This section will show you how to test a RESTful application like catalog service with unit and integration tests. Section 3.4.1, Unit Tests with Unit 5. Unit tests are not aware of Spring and don't rely on any Spring library. They are intended to test the behavior of single components as isolated units. Any dependency at the edge of the unit is mocked to keep the test shielded from external components. Writing unit tests for Spring applications is no different from writing them for any other Java application, so I won't go into detail about them. By default, any Spring project created from Spring Initializer contains the Spring Boot Starter Test dependency, which imports testing libraries like Unit5, Mockito, and AssertJ into the project. So we're all set for writing unit tests. The business logic of an application is usually a sensible area to cover with unit tests. In the catalog service application, a good candidate for unit testing might be the validation logic for the book class. The validation constraints are defined using the Java Validation API annotations, and we are interested in testing that they are applied correctly to the book class. We can check that in a new book validation test class as shown in the following listing.
Listing 3.15. Unit tests to verify book validation constraints.
Then we can run the tests with the following command.
See this code?
Section 3.4.2, Integration Tests with Spring Boot Test. Integration tests cover the interactions among software components, and in Spring they require an application context to be defined. The Spring Boot Starter Test dependency also imports the test utilities from Spring Framework and Spring Boot. Spring Boot offers a powerful Spring Boot test annotation that you can use on a test class to bootstrap an application context automatically when running tests. The configuration used to create the context can be customized if needed. Otherwise, the class annotated with Spring Boot application will become the configuration source for component scanning and properties, including the usual auto-configuration provided by Spring Boot. When working with web applications, you can run tests on a mock web environment or a running server. You can configure that by defining a value for the web environment attribute that the Spring Boot test annotation provides, as shown in Table 3.2. When using a mock web environment, you can rely on the mock MVC object to send HTTP requests to the application and check their results. For environments with a running server, the test REST template utility lets you perform REST calls to an application running on an actual server. By inspecting the HTTP responses, you can verify that the API works as intended.
Table 3.2. A Spring Boot integration test can be initialized with a mock web environment or a running server. View table figure.
Recent versions of Spring Framework and Spring Boot have extended the features for testing web applications. You can now use the Web Test Client class to test REST APIs both on mock environments and running servers. Compared to mock MVC and test REST template, Web Test Client provides a modern and fluent API and additional features. Furthermore, you can use it for both imperative, for example, catalog service, and reactive applications, optimizing learning and productivity. Since Web Test Client is part of the Spring WebFlux project, you'll need to add a new dependency in your catalog service project, build.gradle. Remember to refresh or re-import the Gradle dependencies after the new addition.
Listing 3.16. Adding test dependency for Spring Reactive Web.
Chapter 8 will cover Spring WebFlux and reactive applications. For now, we're only interested in using the Web Test Client object to test the API exposed by Catalog Service. In the previous chapter, you saw that Spring Initializer generated an empty Catalog Service application test class. Let's populate it with integration tests. For this setup, we'll use the Spring Boot test annotation configured to provide a full Spring application context, including a running server that exposes its services through a random port, because it doesn't matter which one.
Listing 3.17. Integration tests for catalog service.
Note: you might be wondering why I didn't use constructor-based dependency injection in listing 3.17, considering that I previously stated that's the recommended option. Using field-based dependency injection in production code has been deprecated and is strongly discouraged, but it's still acceptable to auto-wire dependencies in a test class. In every other scenario, I recommend sticking with constructor-based dependency injection for the reasons I explained earlier. For more information, you can refer to the official Spring Framework documentation, see this link. Then you can run the tests with the following command.
See this code.
Depending on the application size, loading a full application context with auto-configuration for all integration tests might be too much. Spring Boot has a convenient feature, enabled by default, to cache the context so that it's reused in all test classes that are annotated with Spring Boot test and the same configuration. Sometimes that's not enough. Test execution time matters, so Spring Boot is fully equipped to run integration tests by loading only the parts of the application that are needed. Let's see how that works. Section 3.4.3. Testing REST controllers with Web MVC test. Some integration tests might not need a fully initialized application context. For example, there's no need to load the web components when you're testing the data persistence layer. If you're testing the web components, you don't need to load the data persistence layer. Spring Boot allows you to use contexts initialized only with a subgroup of components, beans, targeting a specific application slice. Slice tests don't use the Spring Boot test annotation, but one of a set of annotations dedicated to particular parts of an application. WebMVC, WebFlux, REST Client, JDBC, JPA, Mongo, Redis, JSON, and others. Each of those annotations initializes an application context, filtering out all the beans outside that slice. We can test that Spring MVC controllers work as intended by using the WebMVC test annotation, which loads a Spring application context in a mock web environment, no running server, configures the Spring MVC infrastructure, and includes only the beans used by the MVC layer, like REST controller and REST controller advice. It's also a good idea to limit the context to the beans used by the specific controller under test. We can do so by providing the controller class as an argument to the WebMVC test annotation in a new book controller MVC tests class.
Listing 3.18, Integration Tests for the WebMVC Slice.
Warning: if you use IntelliJ IDEA, you might get a warning that mock MVC cannot be auto-wired. Don't worry, it's a false positive. You can get rid of the warning by annotating the field with suppress warnings. Spring Java injection points auto-ring ring inspection. Then you can run the tests with the following command.
See this code.
Mock MVC is a utility class that lets you test web endpoints without loading a server like Tomcat. Such a test is naturally lighter than the one we wrote in the previous section, where an embedded server was needed to run the test. Slice tests run against an application context containing only the parts of the configuration requested by that application slice. In the case of collaborating beans outside the slice, such as the book service class, we use mocks. Mocks created with the mock bean annotation are different from standard mocks, for example, those created with Mockito, since the class is not only mocked, but the mock is also included in the application context. Whenever the context is asked to auto-wire that bean, it automatically injects the mock rather than the actual implementation. Section 3.4.4, Testing the JSON serialization with a JSON test. The book objects returned by the methods in book controller are parsed into JSON objects. By default, Spring Boot automatically configures the Jackson library to parse Java objects into JSON, serialization, and vice versa, deserialization. Using the JSON test annotation, you can test JSON serialization and deserialization for your domain objects. JSON test loads a Spring application context and auto-configures the JSON mappers for the specific library in use. By default, it's Jackson. Furthermore, it configures the Jackson tester utility, which you can use to check that the JSON mapping works as expected, relying on the JSON path and JSON assert libraries. Note: JSON path provides expressions you can use to navigate a JSON object and extract data from it. For example, if I wanted to get the ISBN field from the book object's JSON representation, I could use the following JSON path expression, @.isbn. For more information on the JSON path library, you can refer to the project documentation. See this link. The following listing shows an example of both serialization and deserialization tests implemented in a new book JSON tests class.
Listing 3.19, Integration Tests for the JSON Slice.
Warning: if you use IntelliJ IDEA, you might get a warning that Jackson tester cannot be auto-wired. Don't worry, it's a false positive. You can get rid of the warning by annotating the field with suppress warnings, Spring Java injection points auto-ring ring inspection. You can run the tests with the following command.
See this code?
In the code repository accompanying the book, you can find more examples of unit and integration tests for the catalog service project. After automating the tests for your application, it's time to automate its execution whenever a new feature or bug fix is delivered. The following section will introduce the key pattern of continuous delivery, the deployment pipeline.